Hello everyone and welcome to today's lesson. We are still on 9.2 quadratic functions, but today's goal is to focus on graphing inequalities. You guys are used to graphing things that look like y equals ax squared plus bx plus c. So you're used to graphing equations. Now we're going to switch it up and make that maybe a greater than, or a less than, or greater than or equal to, or less than or equal to. And we're going to see how that changes our quadratics. All right, so first off, I'm going to relate this to graphing inequalities. So if I have like x is greater than 3, and I'm trying to graph that inequality, we would always put 3 numbers on there. So 2, 3, and 4. So if we have a less than or a greater than, that represented an open circle. Okay, so on this, it's going to represent a dotted line. Okay, and if you remember, we did this in graphing a little bit with graphing lines. If we had equal to underneath, that meant a closed circle on these, or when we were graphing lines, that meant a solid line. Okay, so we're still going to have a dotted parabola or a solid parabola this time. Okay, so now when we shade, if you remember before, if it was a greater than, or if it was a greater than or equal to, we always shaded above the line. If it was a less than, or if it was a less than or equal to, we always shaded below. Now that was with lines, linear functions. We're going to talk about what this looks like now with quadratic equations. Okay, so this dotted and solid are still going to apply. It's going to be more the shading that might be a little bit different. Okay, so when we shade, I'm going to kind of do a side note here. When we shade a parabola, we only have 2 options. We're either going to shade inside the parabola, or we're going to shade everything on the outside. Now, what people get confused of sometimes with shading, they'll think, oh, I'm going to shade on the outside. Well, that top part was not on the outside, because technically, with parabolas going on forever, some of that top part was on the inside, that part right there in the middle, whereas on the edges here, that would have been shaded. Okay, so be careful with that. Sometimes people will have on their graph, they'll have this little bitty U, and then when they shade, they'll shade all around it in one giant circle. But remember, those lines go on forever, so you have to be careful. You either shade inside or you shade outside. And it doesn't matter if it's flipped. So some people want some kind of rule, like if it's greater than, I shade inside. If it's less than, I shade outside. There is no rule with that, unfortunately. All right, so first off, we are going to connect it with either a dotted line or a solid line. So on the first one, because it is just a greater than symbol, that means it's got to be dotted. So I'm just going to kind of fill in those points. We already graphed it with a dotted parabola. All right, over here on the right side, that was an equal to, so that means we have a solid parabola. So I'm going to fill that in with a solid line here. Okay, so next thing, since this was greater than, you think we have to shade above. Okay, so here's what I'm going to tell you to do. Pick your vertex. So find your vertex. Our vertex here was right at 0, 0. Since it's greater than, I'm shading above. Now, remember how I said you had to either shade inside the parabola or outside? Well, where does above fall? It falls outside the parabola. So I need to continue to shade everything on the outside of this parabola. That's where all of my solutions are. There are so many, I can't name them all. I do that shading to show all of the possible answers. So if I chose this point right here of 5, 4, and I plugged it in for x and y, that would be a solution. But if I chose this point, which is 0, -9, that one would not work. It would not be part of our solution. Remember, we always shade our solutions. All right, this one, it's less than. Less than means to shade below. Okay, so find your vertex, shade below it, and that means that we are shading the inside. Okay, so some people get confused. Like I said, they thought since it is a greater than, we always shade outside. Not true, because what if I would have flipped my parabola this way? And if I'd put my point on the vertex and it says a greater than means shade above, I would have shaded inside. So the greater than does not mean inside versus outside. It means shade above or below the vertex. So be careful on that part. That's usually the part where people get confused. All right, so we're going to have steps here. First off, we have to graph our parabola. Okay, so we need to define where the axis of symmetry is. We only need to do this if we have a b term. Otherwise, the axis of symmetry is right on our y-axis, so x equals 0. All right, then we're going to graph the function, kind of like we practiced all week. And then here's the new part. We're going to draw the parabola. We're either going to use a dashed or solid line when creating that parabola. And we're going to either shade above or below the curve. Okay, so we're going to practice a little bit here. All right, I have a b term. I'm going to go ahead and write the equation right here below it. So usually you're used to y equals ax squared plus bx plus c. So I have a b term. I need to make sure I am finding the axis of symmetry first, so which again is negative b over 2a. Okay, so let's plug in here. The opposite of b is positive 2, and a was 1 there. So 2 times 1, which is also 2. So we have 2 over 2. And so our axis of symmetry is at x equals 1. If you remember from yesterday, that is the absolute middle of our graph. So everything is centered around the number 1. Now to find the vertex, we have to plug it in. So this is where I'm going to kind of take off the left side here. And I am just, if you remember from yesterday, taking out the x's and putting in parentheses anytime I see an x. So it is parentheses squared minus 2 parentheses plus 1. Okay, and if you remember from yesterday as well, I told you if you have a graphing calculator or a calculator and you can plug this straight in, that makes a lot of help. Okay, so let's put in 1s for our x's. That would be 1 squared, which is 1, minus 2 times 1, which is 2, plus 1. 1 minus 2 is negative 1, plus 1 is 0. So 1, 0 is our vertex. Move my picture here, give us some more space. And if you remember, we have to do now 2 smaller, so 0 and negative 1, and 2 bigger, so 2 and 3. All right, in terms of which one's simpler, it's always easy to plug in 0, because if you remember, it cancels out the x squared terms, it cancels out the x terms, and it leaves us with our constant, which is 1. And because of that rainbow pattern, those should both be 1. So 0, 1, and 2, 1. All right, let's get some more points here. So I'm going to put parentheses squared minus 2 parentheses plus 1. I have the choice between plugging in negative 1 or 3. I am going to plug in 3, avoid negatives. 3 squared is 9. 2 times 3 is 6, so it's a negative 6 plus 1. That would give us 3 plus 1, which is 4. And again, rainbow pattern, those should be the same. All right, so we have negative 1, 4, and 3, 4. Connect our graph here. Oh, this is where it's different. I almost did it, so I'm sure it happens to everybody. If the teacher's almost doing it. So that was if it was equals, but in this case, we have to go back to our original problem. It's not equals, it is less than. Less than means dotted. Okay, so let's do a dotted. The other thing I recommend is, I know your graph, if you do this little U-shaped here, this parabola, it doesn't go all the way to the top, but I would extend it as far as it could go. That way you don't get confused on the shading. So extend it all the way up, even though it doesn't, we didn't get enough points to show that it went all the way up. Okay, now the shading. This is the toughest part for a lot of people. I see less than. I think I need to shade below the vertex. Well, here's my vertex. So I'm going to shade below, and that means I am shading the outside of our parabola. And I have to shade the entire outside of our parabola. And that's our answer. All of our solutions are where it is shaded. Okay, let's try a few more. This one is nice because there is no B term. Anytime there is no B term, our axis of symmetry is right in the middle at x equals 0. Our y-axis is the line that cuts our graph in half. And our vertex is also a lot easier because I can plug in 0, which cancels out our squared term and leaves us with 8, the C. If you remember, it's always 0C if there's no B term. So let's go ahead and put that point on our graph. So 0, 8. And I have to do 2 smaller and 2 bigger. And in terms of plugging it into our equation, which is -3 parentheses squared plus 8, if I'm given the choice between the two options, I'm going to plug in 1 and 2 versus -1 and -2. So let's plug in 1 first. 1 squared is 1 times -3 is -3, and -3 plus 8 is 5. So we have 5 and 5. I'm going to go ahead and put those on our graph here. Let's do this again, but for 2, 2 squared is 4. 4 times -3 is -12, plus 8 gives us -4. And we'll put those on our graph. Okay, now before you just start drawing in your parabolas, let's see if it's solid or dotted. It is equal to, so that means solid. So we're going to draw a solid line here. Again, try to go all the way to the bottom if you can. And since it is less than, that means to shade below our vertex. Well, if I find my vertex and shade below, that is inside the graph this time. And so all of our answers are inside of that parabola. All right, let's try another one. If you notice, we have a B term here. So B term means, this is the more complicated problem. We have to find our axis of symmetry first by doing x equals -b over 2a. All right, so let's plug this in. The opposite of b is -4. And we're going to do 2 times a. So a is -1, so 2 times -1. This gives us -4 over -2, which equals 2. So our axis of symmetry is at the line x equals 2. Again, I'm going to draw that line on my graph so I know what cuts it in half. And then our vertex is going to be 2 comma something. And then that's right in the middle of our graph. And move these baby spiders out of the way, give us more room here. All right, so again, take out the x squareds. Again, it's a little bit tougher when there's a negative out front. You can always put a -1 if that helps you do it by hand. So this would really be -1 parentheses squared plus 4 parentheses plus 4. You can do that a few times. All right, but I have to find the rest of the vertex first. So let's plug in 2's. 2 squared is 4 times -1 is -4 plus 8 plus 4. Well, the 4's cancel each other out, and that gives us 8. So we have a vertex at 2, 8. Now we want to do 2 smaller, so 1 and 0, and 2 bigger, so 3 and 4. I'm going to start off with the easiest one, which is the 0. Plugging in 0 takes out your x squared term, your x term, and leaves us with the constant, which is 4. And then I'm going to plug in our 1 instead of 3. You could do 3 as well. 1 squared is 1 times negative 1 is negative 1. 4 times 1 is 4. And if I add those together, 4 plus 4 is 8. Minus 1 gives us 7. So we've got 0, 4, and 4, 4. And we have 1, 7, and 3, 7. Now before you connect the points here, let's see what kind of parabola I have. It's greater than, not equal to, so that means we have a dotted versus a solid. So let's make sure our parabola is dotted. And again, like I said earlier, have it go down all the way to the bottom of the page just so you don't get confused with your shading later. All right, it's greater than. Greater than means to shade above. So find your vertex right there at the top. And since it's greater than, we shade above that. So we are shading the outside of this parabola. And all of our answers would be in that shaded region. All right, why don't you guys pause here and try this last one on your own. Okay, so first off, we have to decide what kind of quadratic this is. It does not have a B term. That means our axis of symmetry is right in the middle at the y-axis, or x equals 0. And so our vertex then is the one that's a little bit easier to find. It takes out our x squared term, and it's just negative 4. So down 4. All right, so our original problem was 1/2 x squared minus 4. We already have 0. We're going to do 2 smaller, and we're going to do 2 bigger. Again, I like to avoid the negatives if I can, so I'm going to plug in positives. So 1 squared is 1, and half of 1 is a half. And if I have a half minus 4, that gives me negative 3.5. All right, let's plug in 2 this time. Move my picture out of the way again. If I plug in 2, 2 squared is 4, and half of 4 is 2, and 2 minus 4 is equal to negative 2. Let's graph what this looks like. So 0, negative 4, negative 1, negative 3.5. Same with 1, negative 3.5. And negative 2 is negative 2, and 2 is negative 2. All right, so look at our symbol here. It was equal to. That means we have a solid line. Again, I like to make it go all the way through to the top so it's easier for me to shade. And then when I see greater than, I think above. So find your vertex, go up, and we are going to be shading inside this parabola. All right, if you guys run into any issues or have any questions, please don't hesitate to reach out. All right, see everyone later. Bye.